All right, transformations day 2, a little more complex. Got a few more things to apply here. First things, let's review yesterday. We had a number on the outside, or sorry, we just had a negative on the outside, and that flipped it right over the x-axis. A couple other things we had was we moved up or down, and we also moved left or right. Today we're going to be doing a lot of stretching and compressing. In other words, graph gets really skinny, graph gets really wide. That's pretty much all we got.
Are you recording?
I am recording. What's up? Okay. Everyone good on the subs?
You know,
You only record in this class.
Just didn't do this one. Okay, the first thing, if a is greater than 1, in other words, a number is larger than 1 right here, we're going to stretch vertically, so a vertical stretch, or the graph will narrow. So the graph gets longer. We'll multiply all the y values, in this case times 5, times 8, all that stuff. Questions on what narrow or stretch means?
It's the same thing as steep, right? Steep.
It's steeper. That's great. Next. Cool. If a is between 0 and 1, so like a fraction, a decimal, something between 0 and 1, it's going to do the opposite. It's going to vertically compress. Compress. You're good. What's the opposite of narrow? Widen. Going to widen. So, for example, the difference between these two is that if I draw the quadratic parent function like this twice, this one is going to make it, sorry, I can't do that. This one's going to get narrower, and this one will get, I'll do it, wider. Does that make sense of the difference between the two?
Yeah.
All right. If there's a negative on the inside, so yesterday we dealt with negatives on the outside. This time it's on the inside. Yesterday it flipped across the x-axis, so this time it's going to flip across the y-axis. So we'll say the real technical math definition there, reflect. Flip is great, switch, whatever you want to say, it's just going to go down to the negatives. In this case, it would go right to left, as opposed to yesterday was up and down. All right. Now we got the stuff on the inside. We're done with the outside stuff. We just did reflect across the y-axis. Now we're dealing with b is greater than 1, and b is between 0 and 1. And it's going to be the opposite for what we had there. So when we had b or a was greater than 1, it narrowed or stretched. This time it's going to compress or widen. And so if b is between 0 and 1, it's going to stretch or get more narrow. There's 2 pieces of paper. Alright, so it's kind of opposite of what we think. The bigger the number, it doesn't stretch, it actually compresses. The smaller the number, between 0 and 1, it actually gets narrower, it actually does stretch. Groovy? Last questions or fail later?
You gonna fail it?
All right. Number 1, what's my parent function?
Y equals X.
Y equals X. Done. What's the equation for my parent function? Oh, sorry, my bad. Yeah, that goes up there, and then this would be linear. My bad. Either way.
That's the linear, right?
Yeah, that's the linear. And then what's our only transformation?
Narrow or widen.
Do we have any pluses or minuses? So we're going to stretch by 4. Yeah, For the line, it's kind of hard to say whether it's a, a narrow or widened or whatever. But in this case, we're vertically stretching. So if you're going to write the word vertical right there, that's great too. All right, we got to graph two different things. Let's graph the parent function. How do we graph the parent function of y equals x?
A line going diagonal through.
A line going through
First and third quadrant.
first and third quadrant. So right there.
Killing me.
All right, if I want to graph y equals 4x, that means I'm multiplying all the y values times 4. So instead of being at 0, 0, oh, it's still the same. But this time, instead of being at 1, 1, now it's at 4. Next one's at, instead of being at 2, 2, it's at 2, 8. And then same thing for the negatives down here. The slope is 4 over 1 if you want to graph it like that. Bless you. You can do it that way. Either way. As we can see, our line kind of gets steeper if you want to think about it that way. It gets stretched if you want to think about it that way. We'll be able to really tell with the stretch and compression once we get to quadratics here in a second. Let's get you confused. My blue line is my new one. My black line is my parent function.
Yeah.
So it's going to be like this. Four. The y value if you want to talk about something. Okay, number 2, what's our parent function? Quadratic. What is the equation for that? Y equals x squared, yes. So equation goes here, parent function goes there. What's the transformation here?
Stretches.
Stretch, good. So vertical stretch by what? What's the number? By 2. Let's zoom in a little bit so we can really get after it. My parent function, y equals x squared, that's squaring all of our x values. So 0, 0, 0 squared is 0. 1 squared is 1. About 2 squared? Ooh, it's 4. Maybe y'all can take care of the other side real quick. Square negative 1. Square negative 2.
You got the gas cookie?
All right. Graphing my vertical stretch of 2. We're going to multiply all of our y values times 2 here. So 0, 0 stays the same. Instead of being at 1, 1, now it's going to be at 1, 2. Instead of being at 4, 2, I'm multiplying the y values. I'm going to multiply that one times 2 as well. So what's my new y value going to be? 2, 8.
What would be the domain?
Get all over.
Or the church, the range. You get 2, right?
Those zeros in there. Okay, do we see how it got narrower? My red graph? Yeah. Cool. Moving on. Let's skip number 3. Oh, you want to do it anyway?
No.
Okay, what type of graph is it, just out of curiosity?
Oh, it's a cubic.
It is cubic. And so what would that 1/3 do?
Stretches.
It actually compresses because it's between 0 and 1. It's really hard to see on the graph, that's why I'm going to skip it. But one would look like this and the other one would look like this. So like I said, it's really hard to tell. Let's go to number 4. What's the parent function? It is cubic. Let's know those for the test. Cube root, the equation, y equals
Y equals something cube.
cube root of x. Transformations, stretch, vertically, y. Okay, so our cube root starts off at 0. Now we're taking the cube root of the x values. So the cube root of 1 is 1. What's the next x value I can take the cube root of? 3? No.
2.
4? No.
9.
9? No. 8, because 2 times 2 times 2 is 8. So that's half my graph. Can I take the cube root of negatives?
No.
Actually can. Cube root of negative 1 is negative 1. Cube root of negative 8 is negative 2. Remember this is what this looks like? So now if I'm multiplying all my y values times 2, so 0, 0 stays the same, but everything else gets multiplied times 2.
What do you rotate? Rotate. At the end?
Oh, when you do it? Very.
No, no, in the equation, if it's negative at the end, do it.
It would be negative on each side or negative. Questions? Let me know. I'm gonna get,
Hold on. How do you, never mind.
I'm gonna get better at something. Just sit there. Just man.
So you're multiplying the y value?
That's correct, because the 2 is on the outside.
Yeah.
So it's y.
Yes, ma'am. The x is staying the same. Good question. All right, moving on. All right, between 5, 6, and 7, y'all pick 2. Which one do you want me to do?
5.
I'm gonna do all of them.
I feel like we're kind of beating that horse if we get this stuff. What's our parent function? Absolute value. The equation is y equals absolute value of x. And I hope we're all sitting down because I have 2 different transformations this time. It flips over, so I'm going to say reflects. Well, is the negative on the inside of the absolute or on the outside? Outside. So that just means the same from yesterday, the x-axis. And then what's that 2 do? Yeah, vertical stretch by a factor of 2. Okay, so my parent function, remember what that looks like? What shape is that? V? Yeah, V, right? So let's go to there, and to there. Use your ID if you want a quick line. Okay, we do our transformations in the order they are written in ink here. So we're going to flex first, so that means that it's going to go upside down. And then I'm multiplying all of our y values times 2. So I'm going to have like an upside down V, and then instead of ending at 1, negative 1, it's now at 1, negative 2. So my shape would look something like this.
So wait, so when you reflected it across the x-axis, it became mirror, or?
No, the stretch by factor of 2 became
So it had nothing to do with factor.
right. First thing we reflected, so if I wanted to, I can go back in green here and draw my reflection. So my reflection is my green, and my purple is multiplying all the y values times 2. On to the back, shall we? Alright, 6 or 7, what you want to do?
7.
7 it is. What's our parent function there? Okay, I got a 2 as an exponent. Got a 2 as an exponent.
Quadratic.
Y equals x cubed? Oh, squared. Transformation's got 2 of them.
You always have to put the amount like stretch by and
That'd be good. Do I have any negative signs at all? Number 7?
No.
Yes. No negatives, so that means I'm not reflecting at all. Do I have any numbers on the outside?
Yeah.
Okay, so that if it's a big number, that means stretch. If it's a little number, it means compression. So in this case, it would be a. Okay, so compression by 1/2. And what's that 3 do? This is from yesterday.
To the left.
To the left or right?
To the left.
To the left. 3 units. Draw your parent function. This should not take you that long now. This should just a
no, I don't see it.
really OCD about your points. That's the general idea. Kind of hard to draw a curve line in this thing. Okay. So our moving left and compressing. Let's do it as the order comes. So we're going to compress first. I'm going to draw 2 different pictures for this. My blue is my original. My red is going to be my compression. And then I'll pick the last color for the move. For the shift. Right, so we're multiplying all of our Y values times 1/2. So instead of being at 4 here, it's now at 2. Same thing for the other side. Instead of being at 1, what would my Y value be? 0.5 or 1/2. I wouldn't have any negatives more because I'm not reflecting. Alright, so do we see here how my graph's getting a little wider?
So compression is just narrow, like narrow and
Yes.
wide.
Okay, my green, I'm moving all my points to the left, 3. So 0, 0 is now at -3, 0. -1 and 0.5 is now over here at negative, what is that, 4.5. 1 comma 0.5 is now at -2 comma 0.5. So my final draft here, my green one. I like that side of it. That's a little better.
Okay, so we're making up points, or we just.
We're reading our original and multiply all of our Y values on our blue graph times 1/2. So I get all the red dots. And I take the red dots and move to the left.
Yeah,
Got 3 more, they'll go quick. Here we go.
3 more. Oh. No.
8, 9, 10. Graph of the square root of parent function. That's y equals square root of x. Deflected across the x-axis. So what does that tell me?
minus. There's
And
plus.
negative sign.
Negative sign, right? Horizontal compression. Was horizontal compression stretch on the inside or was it on the outside of the sign? Inside. So horizontal compression of 3. 3. Okay.
I thought it had to be a small distance.
The bigger the numbers, it's going to be compression if it's on the inside. It's opposite.
Oh, it goes on out, we have to have a point for it.
This convection.
I got confused on the whole.
Yeah. Okay, number 9. Let's change this to x-axis, please. Change that to x-axis. Y equals, if it's reflected, what does that mean out in front?
Negative, negative.
Negative sign. Does it say anything about moving left to right at all?
No, you say down.
It says down, so I'm not going to touch that 8 at all. So I'm going 4 units down.
Minus 1.
I'm at +3 already. So if I move down 4,
Minus 1.
negative is correct. That's it. Number 10, last one. Pushing through here. This is just like the ones we had in our notes and our homework last night. We look at 10 and we look to see the x's. Are the x's the same values as the y's?
No.
No, so y equals x, you're out, you're cut. Sorry, man. Let's try another one. Y equals x squared.
Yes,
That's it.
that's it.
That's it?
Yes, so it's
Okay.
quadratic.
So y equals x squared, that's quadratic.
Then the 4.
Okay, I'm going to tell you this. We got 2 transformations.
It's stretch and reflected.
One of those, right?
Reflected is
It did reflect. Here's why. These are all positive.
And those are all.
These became
oh,
negative.
and compressed by 2, right? Or point. It's some,
Reflected across the x-axis, right? Because if I were to plot these, my graph would be up here, and now all of a sudden it's down here. Last thing. If I made all these negative, right? Now they're in the negatives. How did I go from -4 to -6? -2. So is that down, up, left, or right?
That's down. That's up. That's down to.
Got you?
Yeah.
I like it. So my final equation, y equals, what's the reflective? What do I need to sign about? Negative x squared. What's it down to?
Minus 2.
-2. Y'all are awesome. Well done.